let's look at what makes a relation a function. And we're going to start by looking at the definition of what a function is. So a function has exactly one input for each output. So remember that the input are values that are in the domain, and the output are values that are in the range. So to have one input for each output means that there aren't going to be any repeats in the domain. So there's 4 different types of ways that we can look at relations and decide if they're functions or not. The first is from coordinates. So here we have a multiple choice question. It's given me 4 sets of coordinates, and I want to determine which set of ordered pairs represent a function. So I'm going to go back to that definition and think each input has only one output. So I'm going to look at my x values and try to see if there's any x values that repeat. So if I look at A and I look at the x values 4, 5, 6, and 7, I notice that there aren't any repeats there. So that one is the function. So to figure out why the others may or may not be functions, we're going to do the same thing. So if we look at B and we look at all of the x values in B, notice that we have 1, 2, 3, 4, and 5. Again, there are not any repeats, but something different is happening here, and it does not affect whether it's a function or not. Notice that the y values are all 8. So even though the y values are repeating, that is not part of the definition of function, so that doesn't affect it. We only look at the x values. So far, A and B are both functions. If we look at C and we go through those x values, notice that we have 2, 2, 6, 12, and 15. Since there are 2 values that are the same in our domain in the x values, this one is not a function. And then looking at D, notice that all of the x values are 3, so this one is definitely not a function. Now, if we look at relations that are represented as tables, we're going to do the same thing looking at the x values. So if we look at our x values, we're going to look in each table and decide whether it's a function or not. If I look in this first table here, and I'm looking at these x values, -16, 4, and -2, there were no repeats, so this one is a function. There were repeats in the y, but that does not matter in the definition of a function. Looking at our next table, the blue one, now I have 12, 12, and -18. Notice that the 12 repeats, so this one is not a function. Looking at our third table here, we have 16, 1, 16, and 9. Since there is a 16 that shows up twice in our domain, this one is not a function. And our fourth and final table here, our x values are 7, 7, and -11. Since the 7 repeats, this is not a function. The third way we're going to look at are mappings. So a mapping diagram has 2 bubbles. The first bubble represents your domain, and the second one represents your range. So since the definition of a function says that each value in the domain has only one value in the range, we're looking for any repeats, which are represented by the arrows. So in this first mapping diagram, notice that the value 0 in the domain goes to both -1 and 0 in the range. That means that this is not a function. If we look at the one right below it, each value in the domain goes to only one value in the range. That's represented by these arrows. There is only one arrow leaving each number in the domain. Therefore, this is a function. Even though 2 arrows go to 4 in the range, that is not part of the definition, so this can still be a function. Same thing is shown in this third graph here at the top right. So notice that each number in the domain 1, 3, and 5 only have one arrow going from them, even though they're all going to the same value in the range. This is a function. And finally, on the fourth one, if we look at these values, the value 0 in the domain is going to both 2 and 3, which makes this not a function. Our fourth way we're going to look at functions are graphs. So we have to apply our definition of domain. Each value in the domain goes to only one value in the range, and we have to think about what that means visually. So we have been looking for repeats in the x, and so what we're going to look for is we're going to look at each x value and make sure that there is only one y value at that x value. So what we use on graphs is called the vertical line test. It can also be called the pencil test. So what we do is we're going to look at a vertical line and make sure that there is only one point on that line. So if I look at a vertical line anywhere on this graph, notice that each vertical line is only hitting the graph at one point. So this is what we call passing the vertical line test. So at each vertical line it's only hitting one point, so this one is a function. So let's go back to see what that graph looked like. So each x value only had one y value at that point. Let's look at the next one. So if I think about drawing some vertical lines down through here, I want to make sure that there's never a time when my vertical line hits more than one point. So if I look at each vertical line, there's only one point from the graph on that vertical line. So this graph passes the vertical line test and it is a function. Looking at our third graph, if we draw vertical lines, notice that there's several places where it's hitting twice. So here, my vertical line is hitting 2 points on the graph at the same time. This represents two x values, or two y values for each x value. So if I look at this, notice that at -2, if I think about it in terms of coordinates or in a table, just at this particular point, when x is -2, y is about 2.5. And down here, when x is -2, y is at about -2.5. So notice that those 2 points show a repeat in my x's. So that vertical line test tells me that this is not a function.